This video is for Math 70, and this is the first assignment on the rules of exponents. I think we'll have one more of these after this. So here are the rules themselves. Let's talk about this a little bit. If you have x to the a power times x to the b power, you'll get x to the a plus b. If you multiply these exponential expressions, then you add their exponents. So let's look at an example. Let's say you have x to the 7th times x squared. That would be x to the 9th power. So why do we add them if these things are getting multiplied? Well, let's remember what it means to use an exponent. Okay? X to the 7th power means x times x times x times itself 7 times, right? So there's 7 of them. And then x squared means x times itself twice. So what do we end up with? X times itself 9 times. So that's where the formula comes from. Nothing mysterious going on there. Okay. What about this next one? If you have x to the a raised to the b power, that's going to be x to the a times b. So for example, if you have x to the 3rd raised to the 5th power, that will be x to the 15th power. Well, so let's write this out. X to the 3rd raised to the 5th power is going to be x to the 3rd times itself 5 times. So then we go back to our first property of exponents, x to the 3rd times x to the 3rd, and so forth. Add these all up, you get x to the 15th. It's the same thing about how multiplication can be thought of as repeated addition. So that's where these properties are coming from. So now we want to look at using them in some problems. So let's take a look at the assignment here. Okay. So problem 2, we've got 3x squared times x to the 3rd power. So the coefficients will get multiplied separately. You've got a 3 here and sort of a 1 here, right? So we'll come out with 3, and then x to the 5th power. The 2 and the 3 make 5. Well, let's make that clear that that's a 5. There we go. All right, let's see here. Problem 4. We've got negative x to the 5th times 3x to the 3rd. So that'll give us negative 3x to the 8th power. Problem 6. 3ab times 2a. Okay, now we haven't seen this yet, but in a similar way, notice how I said that there was a hidden 1 here, so that 3 times 1 is 3. Each of these has an exponent of 1. So when you do a times a, well, for one thing, that's the definition of squaring something, is multiplying it by itself. So that should lead you to conclude that we're going to get a squared out of it. Okay? Secondly, each of these a's has a hidden exponent of 1, and so if you use our formula over there, 1 plus 1 will give you 2. All right? So that's what's going to be happening in this problem right here. First off, the coefficients just multiply like regular numbers. 3 times 2 is 6. And then a times a is a squared, and the b doesn't get multiplied by anything and just stays b to the 1st power. Okay, so now these things are starting to get a little bit more interesting. Let's see what we've got in problem 8. Okay, so problem 8 is the first one that I think is complicated enough for me to recommend this process where you handle the coefficients and then each variable separately. Okay, and so that's how I'm going to approach the problem. First, I'll look at the coefficients. Negative 4 times negative 7 gives me positive 28. And then I've got a squared times a to the 1st. That That'll make a to the third power, and b times b is b squared, and there's our answer, 28 a to the third b squared. Okay, problem 10. Let's see here. 8xy to the fifth negative 3x squared y, and then 2x. All right, so same process here, right? Still things are a little bit complicated here. So let's multiply 8 times negative 3 times 2. Looks like that should give us negative 48. Then we've got an x times x squared times x again. That makes 4 of them. X to the fourth, right? These are x to the first. This is x squared. That's how we end up with x to the fourth. Then we've got a y to the fifth and a y to the first. That makes y to the sixth power. And there's our answer, negative 48, x to the fourth, y to the sixth. Okay, let's see here. Let's go to number 14. So then we've got x times 3xy times 2y to the fourth. So again, the coefficient here is 1. So 3 times 2 is going to give us 6. X times x is x squared. And y to the first times y to the fourth makes y to the fifth power. Okay. Now the rest of these problems have to do with the second rule of exponents that we talked about, where you raise a power to a power. So let's look at some examples of those. Okay, problem 16. 4x all squared. Now something that I should probably add, and you will have this when it comes time for the final, is that if you have xy raised to the a power, that's going to be x to the a, y to the a. Okay? And so here's the thing, this is actually a very important concept, is that this is saying you can distribute an exponent across multiplication, and also when we get into some more problems in another assignment, we can also do that over addition, right? X over y raised to the a power is x to the a power over y to the a power. Now, that's going to make this problem equal to 4 squared times x squared, or 16x squared. Okay? Now, next week, we'll look at problems where we want to do, and I'll do this in a different color so we don't confuse the situation, x plus 4 squared. Now, this is different. Here, you have to multiply x plus 4 times itself. So if we go back up here, we can write this as 4x times 4x, and there's our 16x squared. Good, okay? Now in this one, and like I said, we'll have an assignment on this at the end of next week, x plus 4 times x plus 4. You have to distribute each one. X times x is x squared, x times 4 is 4x, 4 times x is 4x, 4 times 4 is 16. So you get x squared plus 8x plus 16. Now the reason why I'm talking about this is because here you can distribute the exponent across multiplication or division. Okay? Here you can't distribute. This is one of the most common mistakes in algebra that people make. People look at this and they're like, oh, x squared plus 16. Now, you're missing this middle term, which is actually pretty important. Okay? Now the reason for this is because of the structure of the number system, right? We start with addition and subtraction. Repeated addition makes multiplication, and its opposite division. Repeated multiplication makes exponents, and its opposite, roots. Okay? Because of the relationship between these operations, you can distribute multiplication over addition or subtraction, right? That's what we talked about earlier in the term. 7 times x plus 5, distribute the 7, 7x plus 35. Okay? So that works just fine. Same thing is true of division, right? When we were getting the y by itself, 3x plus 10, divide both sides by 2. Here, this distributes the division across that addition right there. That's what's actually happening when we do that, okay? That works just fine because you're only going one level, all right? And that level is built by doing repeated addition to make multiplication. Same thing here, okay? You can distribute both exponents and roots across multiplication and division, okay? And here are two examples of that. However, you cannot distribute an exponent across this addition because then you're trying to jump two levels, and exponents and addition don't have that relationship that exponents and multiplication have, and also multiplication and addition have. Okay, so that's a lot to talk about. Like I said, we'll look at these problems towards the end of next week, but as I was introducing this concept, I just wanted to make it really clear because this mistake is so common. People make it all the time, and I work really hard to convince people that this works okay, distributing an exponent across multiplication, but you can't distribute an exponent across addition or subtraction. Okay, so there's problem 16. Let's keep working through these problems. Problem 18, negative 4n squared. This is going to be positive 16n squared, right? Because if we go negative 4n times negative 4n, that'll give us a positive 16 along with an n squared. All right, problem 20. Let's see here. I've got 5x to the y power squared. Now that might have been a typo because none of these other ones have variables up in the exponent. I'll go ahead and solve this anyway, all right? So this is going to be 5x to the y power times 5x to the y power. That'll be 25x to the 2y power. And you can get that either by adding y plus y makes 2y, or you can go 2 times y makes 2y. All right? 5 squared is 25. X to the y squared is x to the 2y. Don't be afraid because we've got a variable in the exponent. But like I said, that may have been a typo when I was making this handout. Okay, problem 22. Problem 22. 2x to the 4th y cubed. And what are we going to do? We're going to square that. Okay, so 2 squared is 4. X to the 4th squared is x to the 8th. Y to the 3rd squared is y to the 6th. Remember, when you raise a power to a power, you have to multiply those powers together. All right, problem 24. Negative 2x squared y to the 4th raised to the 3rd power. Okay, negative 2 raised to the 3rd power is negative 8. X squared to the 3rd is x to the 6th. Y to the 4th to the 3rd is y to the 12th. There's our answer. Negative 8, x to the 6th, y to the 12th. And notice how I handled the coefficient and each individual variable separately. Okay? Did this one to the 3rd, this one to the 3rd, and this one to the 3rd. And again, that's okay because they're being multiplied. You can't do that if they're being added. It just doesn't work. Okay. Problem 26. Oh, and this is the last one. We'll see more like this on the second assignment. X squared y cubed, and then 4xy cubed squared. All right, now if you remember your order of operations, we have to do our exponents before we start multiplying between the two parentheses. So this thing is going to stay here and wait, and then this thing is going to be 4 squared is 16, and then x squared, and y to the third squared is y to the sixth. Okay, so now we've gotten rid of that exponent. Now everything's just about multiplication. So we'll have 16x to the fourth, and then y to the ninth. And there we go. Okay, so that's it for this first assignment on the rules of exponents. Like I said, we will have a second assignment that will get a little bit more complicated than this, and we'll look at some more problems where we have fractions and we have to try to cancel some things out in there. As always, if you have any questions about these problems, please let me know. Thanks.